So hello everybody, in previous video we have gone through the Oasis indices and Miller indices. So from the Miller indices what we have come to know, that Miller indices are H, K and L, where H, K, L are the reciprocal intercept of a plane. So by using this value of HKL, we can define different planes by putting the values, just like 1, 0, 0, it will define one plane, 2, 2, 2, it will define another plane, 1, 1, 1, it will define other plane. So we have come to know that the Miller indices can be used, or Miller indices are used for representing to represent the planes. So what is that? Miller indices can be used to represent a plane. Up to this it is clear. But now we have to determine the distance between two successive planes. So successive planes, what is the meaning of successive planes? Successive planes means the planes which are just parallel to each other. It is tagged just one after another. So if these two parallel planes are successive planes, then the distance between these two planes are known as the interplanar distance. Interplanar distance. So if we put the restriction, if we draw the what is this axis, that is two axes, it is a two-dimensional system, so we are putting two axes here. So from the origin, if the distance from the origin to the nearest plane, parallel plane, because it can be considered that origin also contained by a plane which is parallel to these successive planes. So the distance between origin and this plane, the nearest plane, this distance, this is also designated by this distance is also the interplanar distances. Universally, the interplanar distances are designated by, in three-dimensional system, it is designated by DHKL. So, this is the representation of interplanar distances in two-dimensional system. It will give the interplanar distance, which is universally designated by DHKL. So we will deal this condition only, because it is easy to deal with this restriction, with this definition of interplanar distances. And experimentally, how do we determine that one? By X-ray crystallography. With this X-ray crystallography, we can get the spacing of these respective planes to determine the interplanar distances. Interplanar distance for crystals having orthogonal axes. So today's topic is this. So what is orthogonal axes? Orthogonal axes are those axes which are producing the 90-degree angles in between them. So the crystallographic axes OX, OY and OZ These are orthogonal axes if they are producing 90-degree angles with each other. That is, they are perpendicular, mutually perpendicular to each other. Then only the orthogonal axis condition is applied to them. So how many orthogonal axis containing crystal systems are there among the 7 crystal systems? So the answer is there are 3. There are 3 crystal systems having orthogonal axes. What are those? One is cubic system, where A equals to B equals to C, and alpha equals to beta equals to gamma equals to 90 degree. Similarly for tetragonal, where A equals to B not equals to C, and alpha equals to beta equals to gamma equals to 90 degree. Third one is orthorhombic. A not equals to, the condition is A not equals to B not equals to C, but alpha equals to beta equals to gamma equals to 90 degree. And remaining 4 systems, triclinic, monoclinic, rhombohedral and hexagonal, they don't have this mutually perpendicular 3 axes. So these are not orthogonal axis containing crystal systems. So now with this orthogonal, we'll start with this orthogonal system to determine the interplanar spacing DHKL, and from there we'll step by step switch to tetragonal and to cubic system, and the final expression to determine the interplanar spacing. So we'll start with this orthorhombic system. For this we have to draw a diagram like this, where this OX, OY, OZ are mutually perpendicular to each other, and it has a common origin O. Now we are choosing a plane ABC which is cutting the x-axis, y-axis and z-axis in respective point A, B and C. Now from the definition, what we have seen, that the distance between origin and this nearest plane, this is the nearest plane, we are assuming this is the nearest plane to the origin, and we have to determine the distance between O and this plane. For that, what we have to do, we have to draw a perpendicular. We have to draw a perpendicular on this plane ABC. Let it be, we are considering, let it be OM. So OM, it is perpendicular to the plane ABC, which is designated by the Miller indices H, K, L, and this OM, it is producing 3 angles with these 3 axes. With this OX, it is producing theta 1, with OY it is producing theta 2, and with this OZ it is producing theta 3. We are considering that. So from this diagram, what we got that OM, it is perpendicular to ABC plane, which is designated by HKL Miller indices. If the Miller indices are HKL, then the coordinates of O point will be A by H 0 0, For the point B, it will be 0 B by K 0, and for C it is 0 0 C by L. Okay, up to this it is okay. Now we'll apply some trigonometric restrictions to derive the interplanar distance. So OM, the perpendicular OM, it is also nothing but the interplanar distance DHKL. So we have to find out the DHKL. For that purpose, we are connecting this A with this M. We are connecting A with this M point. So, if we try to draw this AOM triangle here, we can represent that one as, that is O, it is M, it is A. So this is 90 degree as per the condition. It is perpendicular, OM is perpendicular to this ABC plane, so it is 90 degree. And we have assumed this angle theta OM with this OX axis. It is theta 1. It is nothing but DHKL, which we have to find out, and it is A by H. If we recall the Miller indices for this arm OA, it will be having value A by H. So for this triangle AOM, for this triangle AOM, the first direction cosine of perpendicular OM, what is that? Is cos theta 1 equals to, cos theta 1 means base OM by hypotenuse OA, भूमि by অতিভুজ, ভূমি মানে DHKL, and OM এর ভ্যালু কত? A by H. তাহলে আমরা কি পেলাম? H by A DHKL. তাহলে আমরা প্রথম ফার্স্ট যে ডাইরেকশন কোসাইন অফ OM, what is that? This is the first direction cosine of OM. Okay, we are going to the second triangle. What is that? That is BOM. For BOM, this angle is 90 degree. Previously, this angle also 90 degree. The restriction we have drawn here, it is also 90 degree. Okay. So, for that triangle, for the triangle BOM, we are trying to draw the that is OM, it is B, and this is theta 2, and it is B by K. So for this BOM triangle, the second direction cosine of OM, perpendicular OM, is cos theta 2 equals to, similarly OM base by hypotenuse OB d HKL by V by K, K by B d HKL. So this is the second direction cosine of OM. Similarly, for triangle, if we connect this point C with M, we will get another triangle, that is COM. For COM, in triangle COM, the direction cosine of perpendicular OM is cos theta 3 equals to nothing but L by C d HKL. So now we got three direction cosines of this perpendicular OM, which is perpendicular to the plane ABC. Now in the mathematics we have that formula, we have some restrictions that for a perpendicular in an orthogonal system, the square of the sum of the directional cosines will give the value 1. So what is that? In an orthogonal axis system, for a perpendicular, the sum of the square of the direction cosine will be 1. So in this system, here we have three perpendicular axes, OX, OY, OZ, and a perpendicular of a plane, perpendicular to a plane OM, whose three direction cosines are cos theta 1, theta 2, and theta 3. So what will be the sum of the square of these direction cosines? That is cos square theta 1 plus cos square theta 2 plus cos square theta 3. What will be that? It will be 1. Okay. So now we are putting the values of cos theta 1, cos square theta 1, cos square theta 2, and cos square theta 3. So what is the value of that? Is for h by a square d square HKL plus k by b square d HKL plus L by c square d square HKL equals to 1. We are trying to simplify that one. D square HKL h square by a square plus k square by b square plus L square by c square equals to 1. H square by a square plus k square by b square plus L square by c square equals to 1 by d square HKL. So this is the formula for determination of interplanar spacing in a orthogonal system. So we are just writing here, and we will try to derive for the formula for the other system. So what is that? 1 by d square HKL equals to h square by a square plus k square by b square plus L square by c square. It is for orthorhombic. It is for orthorhombic system. So we are trying to derive for the tetragonal system. For tetragonal, what is the condition? A equals to B, not equals to C. So what will you do? We will replace B here. Replace B by A, and we will get 1 by D square HKL equals to H square by A square plus K square by A square plus L square by C square, or HKL equals to A square H square plus K square plus L square by C square. So this is the derived formula for the determination of interplanar spacing in tetragonal system. For cubic system, what will be that? For cubic system, the restriction is A equals to B equals to C. And what will you do? We will replace B and C by A, and we will get 1 by D square HKL equals to H square by A square plus K square by A square plus L square by A square. So what will be that? H square plus K square plus L square by A square. Now we are just flipping up and getting the square, removing the square term. So D HKL equals to A by root over H square plus K square plus L square. So this is the formula for a cubic system to determine the interplanar spacing. So in next, what we will do, we will apply this formula to determine the values of respective interplanar spacing, the values of the interplanar spacing of different planes, mainly in the cubic system.